This is the most disliked place on Earth, a desert almost devoid of human life. Yet, a magnificent feat of engineering is being built here, nothing short of a wonder in itself. In the middle of Chile's Atacama Desert, on a mountain peak 10,000 feet above sea level, the construction of the world's largest telescope is underway. This telescope, which will be 40% taller than the Leaning Tower of Pisa when complete, will be able to view distant planets in our universe Osmoth BF5 200 times closer than our naked eye can. And these images will be 15 times sharper than those from the Hubble Space Telescope. Building the world's largest telescope in the driest place on Earth is nothing short of a miracle. The Atacama Desert is the driest area in the world after Antarctica, with some parts where a single drop of rain has never fallen in recorded history. How will this telescope be able to look back in time to see the universe's first galaxies, stars, and planets? How can this telescope help scientists find other Earth-like planets? And most importantly, what challenges did scientists and the construction team face while building a dome as large as a football field in the high altitudes of the Atacama Desert? The Atacama Desert, a unique location stretching over Zambmath BF 1000 along the Pacific Ocean front of South America. This is the Atacama Desert in Chile. After Antarctica, it is considered the driest place in the world. It features unique natural sights that we may be seeing for the first time. Volcanoes are abundant here. Besides this, there are death valleys, thousands of square kilometers of salt-filled deserts, and a unique sequence of fog that is rare worldwide. But the one thing most essential for life is not found here: water. The landscape of the Atacama Desert is such that it doesn't rain here. Some areas have never seen a single drop in history. Because of all these characteristics, the Atacama Desert looks like a scene from an alien planet. Perhaps this is why the European Space Agency tested its Mars rovers here. This extraordinary project is under construction on a mountain near above sea level, from Chile's capital Santiago and from the nearest city. It will offer humanity a chance to glimpse other worlds in space. The Extremely Large Telescope, ELT, the European Southern Observatory, ESO, is building a massive telescope at this spot, named the Extremely Large Telescope, or ELT for short. Although its construction is not yet complete, it's not hard to see why it was given this name. This telescope will feature an enormous mirror with a diameter of 39 meters, not only large but 4 times bigger than the current largest telescope. This mirror can collect an astonishing MathBF 100D is text million years times more light than the human eye. The condition, however, is that not a single speck of dust falls on it. To prevent this, the telescope will be covered by a huge steel dome. The dome weighs about as much as a Mothbov $400 pickup trucks, almost a Mothbov 6000 DR at text tons. 2 massive doors will be installed on this dome, which will remain closed during the day. The dome is so tall that the Statue of Liberty could stand inside it, and it's wide enough to fit an entire football field. A high-tech platform is installed beneath it, capable of rotating the entire telescope at MathBF 360 degrees to easily observe any part of the night sky. It's astonishing to think how the construction team started this complex project in this desolate region of the world, miles away from any population. Especially where there were no roads, no electricity, and no water, and the construction was on top of a mountain. Why the Atacama Desert? For this project, ESO first inspected many locations in Europe, but they finally had to choose this location in South America. ESO is a European government organization with members from 16 countries. The head of the ESO project says there are many reasons for selecting this location for the ELT. The first is that they needed a site for the telescope where there were no cities for miles around. The reason is light pollution. You may have noticed that cities often have light above them even at night, and if there are clouds, they are clearly visible. This light is much stronger than the light of a star thousands of light years away and can ruin the image generated by the telescope. However, many such remote locations exist on mountains in Europe itself. So why was this South American location chosen? It's not enough to protect the ELT from light pollution. A clear sky is also essential. Europe generally has tropical weather, often resulting in clouds. But since the Atacama Desert is one of the driest parts of the world, it has cloudless skies MathBF 320 hours days out of MathBF 365 hours a year, which is crucial for viewing distant galaxies. In Amathbuf 2010, the ESO team conducted tests at various sites and finally found this location in the Atacama Desert to be the best. The Cerro Armazones mountain, Amathbuf 3000 Nordia, text meters omas high. Construction challenges and solutions. The problem was that, like other mountains, Cerro Armazones had a very pointy summit. Construction in this condition would be impossible. Therefore, it was necessary to level the mountain peak to create an area as large as 7 football fields. Imagine a MathBF 3000 text meter, high pointy mountain and having to build a huge field on top of it. This task was difficult and dangerous to do with excavators. Hence, in MathBF 2014, the construction team resorted to explosives. Holes were drilled on the mountaintop, explosives were inserted, and they were detonated via remote control. In this process, the top MathBF 100 dias text meters meters of the mountain were blown off, consisting of a MathBF 4.7 no, text million amalos cubic meters of earth. This was enough soil to fill MathBF 1 1911 Olympic-sized swimming pools. After removing the earth and rocks, the top section was leveled, and a road was built to reach the summit. But this was only the beginning. Although a level field the size of 7 football fields was created on the mountain, a major problem arose, a problem that could have halted the ELT construction forever. The engineering team noticed sinkholes forming everywhere on the mountaintop. They would fill them up, but after a while, new spots would spontaneously collapse. This was the biggest obstacle to laying the ELT's foundation. In fact, the explosives used to blow up the mountaintop had significantly damaged the mountain's core. Cracks formed in the rocks, and the ground began to sink in places. Every few months, there would be movement in the rocks inside, and new sinkholes would appear. To tackle this problem, engineers conducted multiple drills in the field and artificially stabilized the ground with vibration so that all the sinkholes that were going to form would form at once. Finally, the vibration method worked, and after filling the sinkholes, the mountaintop was planned once again. This whole process took the next 5 years to complete. The next stage was laying the foundation for the ELT. This would be no ordinary foundation. This part of the Atacama Desert is a seismically active region where earthquakes are common. To protect the expensive telescope parts from earthquakes, the foundation was separated from the dome above. Several hydraulic shock absorbers were installed between the foundation and the dome to prevent earthquake tremors from reaching the metal dome and the telescope mirror inside. The foundation work was completed in MathBF 2023, and then came the turn of the telescope's magnificent dome. The dome's steel structure was fabricated in separate sections at the base camp below the mountain. Then, these sections were transported to the mountaintop using remote-controlled trucks. Once at the top, cranes joined these colossal structures like connecting Lego pieces. The road network to this part of the Atacama Desert was already quite developed because ESO has another telescope, the Very Large Telescope, VLT, only ko MathBF 20 zias text $1,000,000 from the ELT site. So, the existing road network was extended to Cerro Armazones for the ELT. The mirror and adaptive optics. The reason the ELT will be the world's largest telescope is its 39-meter mirror. Currently, a structure is being built inside the dome to support this huge mirror. To gauge its size, look at the worker standing on the frame. This 39-meter mirror will be assembled from a total of MathBF $800 small pieces. Its function is to multiply any light coming from space and send it to the secondary mirror, M2. From M2, the light will go to M3 and then to M4. M4 will make the image sharper, and for this, powerful laser beams on the dome will be used. These lasers are usually set to a wavelength that excites sodium atoms, a MathBF 190 Dries or text, Kamiarnoitjono, high in the atmosphere, making them glow and creating an artificial star. The telescope uses this artificial star as a reference point to determine in real time how the atmosphere is distorting or blurring the light. Once the atmospheric distortion is known, the blurriness in the telescope's image is easily eliminated. This entire process is called adaptive optics. After removing the blurriness from the image at M4, the light goes to M5, where the image is corrected and sent for processing. The ELT's scientific goals. We've talked a lot about the telescope's incredible workings. The biggest question here is, what will the ELT be able to do? The ELT will be the first ground-based telescope capable of taking direct photographs of exoplanets, planets outside our solar system, especially those with the potential for life. Currently, these exoplanets are studied indirectly. Through direct photographs, we can determine the planet's atmosphere. The atmosphere can reveal whether there is water or not, carbon dioxide or oxygen, or perhaps a creature causing pollution like on Earth. Because of the ELT's massive mirror, it will be able to collect a great deal of light, allowing us to see into the earliest days of the universe. If you don't know, light has a fixed speed and cannot travel faster. Taking advantage of this, we can easily see into the universe's past. A simple example of this is the first ray of our sun. When the sun rises every day, we are actually seeing the sun's past because it takes about 8 minutes for sunlight to reach the Earth. The Hubble Space Telescope can look back 4 billion years into the universe. That means its mirror captures the faint light that left the universe MathBF 13.4 billion years ago and reached Hubble today. In contrast, the ELT's MathBF 39X text-a-meter mirror is capable of seeing light MathBF 100 radius text million years further back than the Hubble telescope, meaning MathBF 13.5 billion light years away. According to scientists, the Big Bang, which created our universe, occurred mathbofto 13.8 billion years ago. This means the ELT can capture a scene from just AMMATHBF 300U, text a million years after the universe's birth. It is also important to know that while the ELT is huge, it will only be the largest among mirror-based telescopes. Radio telescopes, like the one in GoldenEye, use a very large dish. Instead of mirrors, these telescopes look into the past using radio waves, and then computerized processes create an image. But for direct viewing, the ELT is said to be the world's largest telescope yet. Cost and completion. As for the cost, the ELT is estimated to cost an astounding AMMATHBF $1.6 billion, AMMATHBF 13,600 crore rupees. This is about the same amount of money that was spent to build the world's tallest building, the Burj Khalifa. Experts estimate that the ELT's construction will be completed in 2029. Once fully ready, it might answer the biggest question. Are we truly alone in this universe, or does life also exist on an Earth-like planet thousands of light years away? We hope you liked and shared this LearnSpear video. Thank you very much for your loving comments. See you in the next fantastic video.